here to start before we get going. So Sunday, the first problem set is due, right? Have we talked about how to get stuff into OneNote? If you are, I do my stuff on paper. Let's talk about that then for a minute, right? So everything that gets turned in, assignment-wise, goes into your OneNote. So if you look in your OneNote, you'll have like stuff at the top and then your name. So Allison, I'm going to use yours for an exemplar. Is that okay?
Yeah.
Okay. So you have two tabs in here. You have a notes tab and a homework tab. Where do you think you're going to put the homework in?
Homework tab.
Yeah, there you go. That's using your noodles. All right. So the easiest way to do this, if you are a pencil and paper person, if you're writing your stuff in OneNote, you're fine. There's nothing that needs to change. And you can go back and forth and do some of both. Either is any, it's fine. If you're taking it from paper, the easiest thing to do, you take out your cell phone. Go ahead and do that if you want to follow along. If you want to try doing it today in class, where you can see it for yourself, you're welcome to do that. No one's going to yell at you for having your cell phone out because I'm inviting you to do so now. Is we're going to take a picture of our assignment. We're going to email it to ourselves, and then we're going to insert that image into OneNote. Okay? For those of you that have an iPhone, the easiest way to do this is if you open up like your Notes app and you have an iCloud folder. If you make a note in the iCloud folder, there's like a little camera option. It'll actually scan images for you. So to give you a really nice resolution picture, and it'll cap just like a sheet of paper. It's already set up to kind of do that. So if you pick that option, and there's like a scan documents option, and you just like take your sheet of paper and hold it above it, so it'll like cap it. Just hit save, and then you do like the little sheet of paper with the arrow up, and you can just email it to yourself. Go ahead and try. If you have stuff, just like take some random sheet of paper with your name on it or whatever. You'll email it to yourself. Once you email it to yourself, my recommendation is to save that file to the desktop, because the easiest way to get it into your OneNote is to just like grab the icon and like drag it into a blank page like this. And if you let go, it'll give you two options of attach file or insert. You want to pick insert printout, and you'll get like the nice sheet of paper in, right? Like, here you go, Allison. There's some comments I made for some calculus kids homework that you now have in yours. I deleted it out of there because I don't think you probably want it, but it was just for grins. So take a minute, try it. If you have a cell phone and you have an iPhone, you want to try doing the scan document, try that. Get it into your OneNote. See if it works. See if you can do it. If you don't have an iPhone, I don't know if there's a scan thing for Androids or not. Just take a picture if you're confused and just do the same thing. Email it yourself, drag them in. If the picture is like crooked, like here's a picture of some bears eating apples. If you right-click them, they'll have like, oh, I guess this one doesn't have an option to, I thought it would have the option to turn it. If it's crooked, if you right-click on it, it'll have like rotate 90 degrees as an option. You know, like if it's, oh, that's facing the wrong way. Like if you could rotate those for me so when I go to look at it, it's like easier for me to read. That would be great. If you're doing scans, though, it shouldn't ever really do that for you. Does that feel okay, guys? We get the gist?
Where do we send it?
Send it from?
Yeah, like from my phone. Like where do I click the button?
So you'll send it as an email to yourself, to your NDP school account, because you got to get it onto your computer, right? And that's probably the easiest way to go from your cell phone to your computer, is to just send yourself an email with the image as an attachment or whatever, or images if you took like several of them.
Yeah, but on the Notes app, there's no button. Send. Yeah, that's my plan. Like, look, that's. Oh, it's chips. Oh, it's. Oh, it's the last year. Oh, no, I would never take a science class. Science is like the worst subject of all time, in my opinion.
Yeah, what's so bad about it?
It is just so hard.
What's
chemistry and all of that, like studying atoms and stuff. Like, I just don't see how knowing like about atoms and stuff. Just me personally.
That's like the fundamental building block of reality.
Yeah. Other people, like, but for me, like I don't think it's gonna help me in my future. I don't think I'm gonna have to know about how iron becomes
Iron becomes a penguin? Is that what you said?
liquid.
A liquid? That would just be melting.
Yeah, I know.
Yeah.
But like, I don't even remember anything.
Okay. All right.
No, I remember a little actually now. I remember the periodic table.
The periodic table. Okay. All right. How are we feeling on that, at least? Like getting stuff into your OneNote? Feel a little better after seeing like, oh, is that all you want me to do with it? Yeah, that's all I want you to do. The one thing I would say though is like, as you're naming these things, you know, like give it a name that like makes sense for me. You know, like title the thing something like this. So when Mr. Kulik goes and looks at it, he's like, what is, okay, where's your chapter 1, number 1 through 18? And it's like, oh, it's right there. And when you get, you know, the next assignment, you know, like, you know, make a new page or whatever and call it something, you know, something sensible where it's like Mr. Kulik knows what the heck he's looking at. So when he's looking at the numbers, he's like, okay, yep, that looks like everything is there. You know, just to make my life a little bit easier. Okay. All right. So that's good. And again, you can, if you have your syllabus sign-in sheet, you want to submit it this way, perfectly fine. I'll see them when I look at homework again on Monday. I just looked at because I went and, you know, we were getting close to syllabus turn-in time. You know, just seeing nobody had really given me any paper copies. I'd forgotten to ask for paper copies. But I looked at the OneNote, see if anybody did that. And then I just put missings if I didn't see anything, just to help you ask about it so I would remember to say something. But we still need to make sure we turn these things in. Nobody's actually getting graded down for this. It's not that kind of an assignment. I don't really care about it. In like time-wise, I mean, eventually I'd like to have it. But like whether you did it today or tomorrow or next week, it's fine. Just get done eventually, right? I'm not going to lose my mind over, oh my gosh, you were late. And it's like, it's not a big deal. All right. Great. What else are we planning on doing today? Okay. Nap. Is that what you said? So reminder to just going back to the syllabus. Here I want to point something out to us. Oh my gosh. OneNote, hurry up. Where were they? Homework quizzes. So homework quizzes, there will be at least one quiz per chapter. The homework quizzes will be unannounced, based on recent homework assignments and closed book. Graded on a 10-point scale based on overall demonstration of understanding. Guess what we're going to do next? The homework quiz. But before we do that, let's take some questions from homework. Right? So if there was some stuff on here you still weren't feeling great about, this is Mr. Kulik telling you that, like, hey, make sure you're paying attention right now for if you've been like kind of spacey. And if there's stuff you want to talk about, like, let's get it done and do some talking, right? Will, we'll start with you. 16? Absolutely. All right. So it says use a function grapher, the AKA my graphing calculator, to identify and classify all local maximums and minimums. Round your answer to nearest hundredth. So we're looking at number 16. So I'm just going to start by turning on my old friend graphing calculator, pressing the y equals button, clearing out any stuff that I might have had typed in there, and typing in my equation 16 just as it appears on my calculator. To get these bigger exponents, like exponent 3 and 4 and stuff, we're just going to use this like caret up button above the division symbol. That moves your cursor into the exponent. You can type whatever number you want up there. The thing you have to remember now is after you've typed in the 4, for example, is to press the right arrow to move your cursor back down to the main line so you don't just like type the rest of the thing in the exponent and realize, oh, shoot. So I did that. And then I use my calculator for like all these different math classes, and I zoom in and change windows and all the stuff all the time. So I'm going to just press zoom standard to graph this instead of the usual graph button, because I don't know if I've goofed around with my window or not, but zoom standard is usually what I want. So I'm just going to do that to move it back to a normal window before I start moving things around again. Just because I don't remember where I was at, and it just saves me a step, because it's like, you know. All right, so if I look at my picture, let's see, I see a local minimum here. I see a local maximum there, and I see a global minimum there. Nick?
Question. So like, if there's a point like going straight up, so it's like infinity. Is that like like no global maximum?
Correct. So this one doesn't have a global maximum because we have an arrow pointing up. So if you have a graph where one arrow points down and one arrow points up, you can't have any global extrema because there's always something lower because of the arrow going down. There's always something higher because of the arrow going up. All you could have is locals. Everybody's good? Okay. So let's show you how to use the calculator to find these actual specific points, right? The calculator functions that operate on a graph are all located in this calc menu. So to access this calc menu here, we press second because it's a blue command, and then the trace button. So this is where all the operations that you can use on a graph live. If I look at this, if I'm looking for that first local minimum, which one of these commands sounds like the one that I want to use? Minimum. It's nice that they named them so conveniently for us, right? So I'm going to go ahead and press enter there. And now if I look at my calculator is going to ask me 3 questions. It needs me to give it 3 things before it can find that minimum. The first thing it's asking me for is a left bound. So what I'm going to do is I'm going to take my cursor, which I can see flashing right here, and I'm going to move it so that it's somewhere over on the left of that local minimum. So somewhere over here. So I'm just going to use the left or right arrows to move my cursor. And really anywhere over here is fine. I like it right there. That seems like a good spot. I can definitely tell it's left of the minimum. So I'm going to go ahead and press enter. Now it's asking me for a right bound. So I'm going to do the same thing. I'm going to move my cursor to the right side of this. But I want to be a little bit careful about this because there's some other extrema to the right. I don't want to move it past the next extrema. So the point I want is going to be somewhere between that local minimum and that local maximum. But anywhere in that little section would be okay. So we'll just move over there. That looks good. I'll press enter. And then it wants a guess. The guess doesn't really matter. Just press enter where you're at. It's not going to be any faster by moving it close. You could if you wanted to, but it's going to take more time to move it than it will the calculator's additional time to find the minimum. So there's my first local minimum is at negative 1.53 comma negative 169. So that's a local minimum. Will, so far so good?
Yep.
Okay. Let's find that maximum next. So again, we're going second and then trace. From this menu, we're going to choose the maximum command. Shocking, I know. And we're going to do the same 3 questions, left bound, right bound, and guess. So here, again, we have extrema on either side of my maximum. So when I pick my left bound, I want to pick it somewhere between the maximum and the next extrema. So I don't want to go past that next extrema, but somewhere in that little section looks good. And the same thing with the right bound. I'm going to move my cursor, but I don't want to go past that next local minimum. I want to be somewhere in between that the goal or that maximum and then the local minimum or the minimum to the right of it. And then the guess doesn't really matter. So my next one is negative 0.10305 or 350, I think. Not 353. Oh, it was 305. And then my last one is a minimum. So when I go second and trace again, I'm going to pick the minimum command. And again, I have to be a little bit careful with my left bound because there's extrema to the left of this global minimum. So I want to make sure I don't go past that next extrema. So I want to be somewhere between that maximum and the global minimum. That spot looks okay. And then move my cursor somewhere to the right of it. And here it doesn't matter because there's no extrema to the right of it. So as far right as I want to go is fine. Don't go too far though. And then a guess right where I'm at will work. So 163, 480, negative 486. So those are my extrema. Is everybody cool with how I found those? What if I also, this question doesn't ask for it, but what if I asked you also to give me my intervals of increasing, decreasing? Billy?
Do you want me to do all?
Sure!
Alright, so the first one would be negative infinity.
Okay, is this increasing or decreasing? No.
Oh, it's
Let's do this so I can look at them both at the same time.
it's decreasing.
Okay, so I'll make one of these. Okay, so we're going negative infinity. Yeah, I know that always gets a parenthesis, so I'm going to stick that on there right away.
Negative infinity and then to negative 1.53.
Great, that's the x-coordinate for the first minimum.
And then you put a u.
Okay,
And then you do negative 1.53. This is the increase.
Yeah,
So
okay.
negative 1.53.
good.
And then it would be to negative 0.10.
Good. So again, we're starting at the local minimum, and we're increasing all the way to the local maximum. Again, these intervals are always x-coordinates. The y's do not matter to us. We're never going to write those down. We're writing intervals. I know the intervals look just like the points, and that can be confusing, but context matters, right? An extrema is a point. An interval is a set, right? It's x values only. Okay, continue on, Billy.
And then the next one's going to be decreasing.
Uh-huh.
From negative 0.10
Great.
to 1.63.
Excellent.
And then the last one's going to be increasing from 1.63 to constant.
Great. We feel okay on how Billy did that. The takeaway here, what we want to notice is that the boundaries for my intervals of increasing and decreasing are the x-coordinates for my extrema, right? Your extrema are where your graph changes from increasing to decreasing or decreasing to increasing. Joey.
This says find all local maximum. Does it include the global maximum?
Yeah, globals count as locals also, because if you think about the definition, it's like a global minimum is the lowest point in its neighborhood. Well, certainly if I look at a little neighborhood, the lowest overall is still a local. But it's just, you know what I mean? Yes.
Will we be able to go over a little bit of like 1.1 and
Absolutely. Yeah, you can ask about anything we've assigned up to this point. All of 1 through 18 is fair game. Will, are you happy though with what we've done? This was your question, so that's why I'm circling back to you.
Could you do number 3?
Sure. All right, so 1 through 4, and we're talking about number 3 right now. We're asked, do these relations represent a function, right? So right now, these are given to us as equations. It's pretty tough oftentimes to tell if an equation represents a function or not. What would be a better representation for us? Well, like a graph, right? So that's what I would be planning on doing, is I want to take these equations, represent them as a graph, and use the graph to tell if it looks like a function or not. Now, the tool I'm going to use to turn this equation into a graph would be my calculator. To get the thing into my calculator, it has to be y equals, which is where you were going, right? So that would be my first step that I'd want to do with number 3, is I'd want to take this and rewrite it so that the y is by itself, so that I can type it into my calculator and just look at the picture. All right. So what should I do first to get the y by itself?
Take the square root of this.
Not yet. Divide by 2. So what you want to remember, you remember the order of operations, right? If you're solving, you want to go in the reverse order. So the first stuff you'd want to deal with would be addition and subtraction. None of that to undo. Next would be multiplication and division. That we have going on, right? We have 2 times y squared. So I definitely want to do that first. And then we'd be looking at undoing exponents. So there's going to be the square root of both sides. Now, what do I have to remember when I take the square root of both sides of an equation? Plus or minus. Got to stay on top of that. That's easy to forget. We've said that a bunch of times now over the last couple of days, but I bet still half of us will forget to do it if I sneak one in there. All right. Now, this is still a bit of a problem for us typing into our calculator because we don't have a plus or minus button on our calculator. Yeah, so we just split it into 2 different graphs. That's exactly right. We're just going to do one where it's positive and one where it's negative. And then just graph them at the same time. And the total picture is what we're considering. So I'll do the square root. You press second and the x squared button because you see in blue is the square root above it. The blue commands you need to press second to get to. And then when you're typing in negative root of x over 2, you need to make sure you're using the negative sign key and not the subtraction key. Subtraction and negative are different operations on your calculator. If you typed in the subtraction symbol, it would have given you a syntax error because it's saying, I don't see 2 things you're trying to subtract. And it would not like that. All right, hit graph. So that's my picture. Is this a function? No, why not? Fails the vertical line test. If you're looking to, like it says, explain your reasoning, how would I explain this? I'd sketch the picture and then draw a vertical line and say it fails the vertical line test. That would be my work.
Could you do one more?
Yeah, we can do as many as you guys want. It's no big deal. We're not in a rush.
Homework, are you like turning it on one note? Does it have to like write?
No, it's completion.
How much switch?
Yeah, I mean, as we're doing this, having your homework out and like changing things and scribbling stuff out and making notes is exactly what you should be doing. And your homework is graded on completion, not correctness. Because I'll tell you, I don't know about you, but the first time I try something usually doesn't go well. That's what the homework is. It's the first time we're trying it. Joey? 6. Yes. And then AJ?
Yeah.
Okay, you're next.
Okay.
Okay. I just want you to know, I saw you. Somebody's got to go before somebody else. He was sitting in front of you, so my eye saw him first. But we'll certainly, whatever your question is, we'll take yours next. Okay? Maybe because it's an even and he couldn't look up the answer in the back of the book and he wasn't sure. Seems like a reasonable place to be at. All right. So for these domain problems, what I want to do is I want to start by looking at the operations involved in my function. So if I look at x squared minus 1, what operations are involved? Subtraction and squaring. Okay? So let's look at these operations one at a time. What I'm going to ask myself is if I take two numbers and I subtract them, do I always get another number back? Yes. So that tells me subtraction is not going to restrict my domain at all. Okay? If I take a number and square it, am I always going to get another number back? Yes. So that does not restrict my domain at all. So my domain should be everything. There's no exceptions. Every number should work. How do I write every number as an interval? I write it as negative infinity to positive infinity. And I'm done. So there's nothing really to do because there's no restriction. There's no number that's going to cause a problem or no operation that can cause a problem. If all the operations are like addition, subtraction, multiplication, exponent, nothing bad can happen. What are the operations that bad stuff can happen? Division and square roots. Those are the two things that we have to worry about. What bad stuff can happen with division? Dividing by 0. What bad stuff happens with exponents? With radicals. Square root of a negative is bad news, right? So those are the places we have to worry about. I'm going to take AJ's question and we'll get you, Nathan. What's up? Age 14? Sure.
I just had a question on one of the parts.
On what?
One of the parts of the question.
Sure. Yeah, of course. Man, you guys are tough on each other.
It's like half water, half Gatorade, just water.
All right. Slide that in there. We'll make that big so we can look at it.
Can you do the intervals?
Yeah. Okay. So AJ, you said you just had a question on the part. Nick wants to see the intervals also, so we'll do both of those. We'll deal with your specific part question first.
So when I'm writing the decreasing intervals, do I have to write -3 to 0, then 0 and 2, or can I just write -3 to 2?
Great question. Right, so we have this part here. So AJ is saying, okay, for my interval decreasing, do I do -3 to 0 and then 0 to 2? Or should I write -3 to 2, right? So I'm going to go back and look at the very specific mathematical definition for what decreasing means, because this is a place where I'm going to need the precise definition to answer this question that you're asking. And I want to, I'm going to do it. I could tell you the answer, but I want to show you how, why this is the answer. Okay, so it says f is decreasing on a given interval if for any 2 points on the interval, a positive change in x results in a negative change for f of x. So, what that means is, if I go back and I look at this problem, if I include 0, and say I pick a point or an x value here and the x value there, is that continuing to have a negative change in y? Is the y going down? Sure is, right? And no matter how close I'm getting to 0, it's still kind of going down to 0, right? Okay, so that would tell me that 0 looks good. Let's go from the other side, though. Let's say I pick 0 as my starter, and I pick something after it, right? Is it still kind of heading down? Yeah. So that tells me 0 should still work as a point. Anything I pick before 0 still slopes down. Anything I pick after 0 still slopes down. The fact that it levels out there a little bit is okay. That point 0, or the point there at 0 has a special name. It's called an inflection point. And what's happening is the graph is changing in concavity. So like this piece is concave up. Like if I was to pour water into it, it's kind of like a bowl and would catch it. This half is concave down. If I poured water on top of that half, it would like run off like a roof. And that point is an inflection point. It looks weird, but that's what's going on there. But it doesn't affect our intervals of increasing and decreasing. It would reflect a change in concavity, which if you take a calculus course, you'll talk all about. But that's beyond the scope of what we're trying to do right here. But that was a great question, right? Because it's a point that's included, and it seems like it's kind of weird there because is it flat there? I can't really tell. So you asked exactly the right question because that's what you're supposed to look at when you see this problem. Go, But that's it. So that's our answers. You should write it this way. And then, Nick, you wanted the intervals. So let's finish that part up. So we have an increasing interval here and another increasing interval there. We got all the decreasing already there. Mm-hmm. Yeah. So -3 to 2 is the decreasing one, and then 2 to positive infinity was the other increasing piece. Again, we're only looking at x coordinates, right? When we're writing our intervals. Unless you're doing range. Range is about y's, but increasing, decreasing, etc., we always use x's to describe. How we feeling so far? Is this clearing up a little bit? Those of us that had some questions, or we're feeling less certain, hopefully we're feeling a little bit better. Billy?
Could you do number 8?
8?
That works.
All right. So, if I look at 8, what operations do you see going on?
Division.
Division,
X squared.
a squared,
And subtraction.
subtraction. Now we've talked about subtraction, that doesn't matter. We talked about x or a squared, doesn't matter. But division does, right? And we know that when we're dividing, we can't divide by 0. So my restriction comes that the denominator, or the divisor of my division problem, can't be 0. That's the restriction I need to make. Now what I'm going to do is I'm going to solve this equation, transform it into something on the number line, and then write my interval from that. Okay? So to solve this, what do you want to do first?
I'll add 1 to this.
Great, let's do that.
And then I want to take the square root.
Good. And what do we have to remember here?
Plus.
Yep, square root of 1 is just 1. So we have that. Now this is equivalent to just saying x cannot equal -1 and x cannot equal +1, right? So let's translate this now on that information onto the number line. So it says x cannot equal -1. So at -1, open circle because it can't be -1. At +1, open circle because it can't be +1. Any other x though would be fine, right? 2 is not equal to -1 or +1. So like if I'm drawing my number line, that's what I'm drawing, right? So if I look at that, when I look at this, it looks like I have 1, 2, 3 intervals that I'm going to need to write, because I have 3 sections of that number line. This first interval has the left arrow, so it's going to start with negative infinity, and it stops at -1. Now the infinities always get a parenthesis, and the -1 is open, so it gets a parenthesis. Excellent. Okay, now we'll do the middle section. That starts at, and it ends at, and they both are open, so they both get, great. And then the last section starts at, great, and those are all parentheses again. And that's your answer. Again, it looks easy when I do it. Don't be deceived. This is like year 16 of being a math teacher. Imagine doing the same thing for 16 years. How good would you be at that? Yes. Sure. Okay. So we see subtraction doesn't matter. Division, that matters. The denominator can't equal 0. And then we see a square root. That matters. I know the stuff under the square root can't be negative, so it has to be greater than or equal to 0. So far, so good. Square root of 0 is 0. That's okay. Now, if I look at these two things, if both these two things have to be true, if x can't be 0, but it needs to be greater than or equal to 0, that's really just greater than 0, right? So when you said it can be 0, like, well, the square root part can be 0, that's fine, but because it's in the denominator, we can't have the 0 there. So you're right to think like something fishy. I was going to take care of it in just a second, but let's rush to do it since you were already had your hackles up and knew something was up. That's great. All right. So we draw our number line. So open circle at 0, going to the right because it's greater than. So that's just going to be one interval because it starts at 0, contains the right arrow, which is 0 to positive infinity. 0 is open, so it gets a parenthesis. That's all there is to it. This was the tricky part, catching that those two things are going to turn into just greater than 0. Or you might have been able to look at it and just been like, can't be 0, has to be positive, greater than 0. But, all right. You guys ready? Enough? Ready as you're going to be right now today? Yeah. Anyways, okay. It's just 3, man.